Hello, this is question 17 on your June 2018 paper 2 from AQA. You have a buggy is pulling a roller skater in a straight line along a horizontal road, means of a connecting rope as shown in the diagram. The combined mass of the buggy and the driver is 410 kilograms, a driving force of 300 newtons, and a total resistance force of 140 newtons act on the buggy. So we can draw them. Driving force in this direction is 300 newtons. Resistance force in this direction is going to be 140 newtons. The buggy and the roller skater have an acceleration of 0.2 meters in that direction. Yeah. Find R. R. What is R? Sorry, I didn't read this bit. The mass of the roller skater is 72 kilograms and a total resistance force of R newtons acts on the roller skater. So against the motion, the resistance force in this one is R, and we don't know that value. Yeah. Then in the string, in the rope, we will have a tension pulling this way and a tension pulling this way. And find R. So if what we are going to do, if we don't want to have R in our equation because we don't know it, is to put both things together. Remember, when we have connected particles, we can put them together as a single one. So it's like having a particle with a driving force that way of 300 newtons and two forces in the other direction, which is 140 newtons and R. Yeah. And the new mass is the combined mass of both of them. It's like if we collapse them together. So it's going to be 410 kilograms from this one and 72 kilograms for this one. So our mass of this new particle is going to be 482 kilograms. Yeah, and that's what we have. If we apply the equation of motion to this, so resultant force is mass acceleration, the resultant force is going to be 300 minus 140 minus R. So forces pointing in the direction of the motion first minus the ones opposed to the motion. So this is going to be 300 minus 140 minus R is going to be mass. So the combined mass, 482, times acceleration, which is 0.2. And from here, just making R the subject, we have that R is 63.6 newtons. And that's it. So it's quite simple. Then the next says find the tension in the rope. So to find the tension in the rope, we are going to work or with the buggy or with the roller skater. This one is going to be simpler because it has only two forces, while this one has 1, 2, 3. So I would choose this one. But in this occasion, we have found out R. And it could be wrong, yeah? So we could have made a mistake here. It's not, because I have checked the mark scheme to see if it's right, but in an exam, it could be wrong. So I would be using this one instead because I know these numbers are correct, yeah? Just in case. So if we apply the equation of motion just to the buggy, we have force is mass acceleration. So the resultant force is going to be 300 minus T minus 140, yeah? So this for the buggy is 300 minus 140 minus T is the mass of the buggy with the driver, which is 410 times the acceleration. 410 times 0.2. And from here, very quickly, we find that T is 78 newtons. If you choose to do with the roller skater, you will get the same answer, yeah? So your resultant force will be T minus 63.6 equals 72 times 0.2, and you will get that T is the same, yeah? As just in an exam, I would always use numbers that they give me instead of the ones that I find, if I can. Next, it's a state a necessary assumption that we have made. We have assumed that this tension is equal to this tension, and that happens when the string is, for example, inextensible, and they don't say, but that's how we work in all these questions. So assuming we are they actually don't say, even that we are considering the particles. So that's another thing you could say. You are assuming that the buggy and the roller skater are particles, or that the string is light and inextensible. So we could say that, for example, string, light and inextensible. They don't tell us. We have assumed it because otherwise we don't know how to do the question, right? Next, it says the roller skater released the rope at point A. When C reaches a speed of 6 meters per second, C continues to move forward, experiencing the same resistance force. So the person released the string, so that means we don't have this tension anymore. It's just skating, but still this resistance force is the same. The driver notices a charge in motion of the buggy and brings it to rest at a distance of 20 meters from A. So applies the brakes or wherever, and then it stops in 20 meters. Determine whether the roller skater will stop before reaching the buggy. So we have the roller skater, we have the buggy. The buggy moves for 20 meters and stop, and we need to know if this skater moves for 20 meters less or more, yeah, because it will be the way of checking if this one reaches the buggy. So we are going to find the distance that this moves before stopping. We know an initial velocity, which is this 6 meters per second, and every time we are asked about distance, display velocities, times, things like that, we have to think about SUBAT. Yeah, we are going to work with constant acceleration. We need to find this distance to see if it's greater than 20 meters, yeah, or smaller or equal. Initial velocity is 6, final velocity is 0. We don't know this acceleration, so this acceleration is the deceleration of the skater. So once there is not a string here pulling, we don't have this acceleration anymore. Yeah, so this roller skater is going to decelerate until it stops, he or she stops. So we need to find that deceleration. So we are going to apply the equation of motion to the roller skater in that situation. So we have the roller skater and only a resistance force in this direction, yeah, and it's moving in that direction with an acceleration that we need to find. So if we apply here in one side force, mass, acceleration, resultant force is going to be 0 in this direction minus r, minus 63.6, because they say that doesn't change, is the mass, which is 72, times the new acceleration. And the new acceleration is minus, because it's deceleration, so it's correct, 0.883 something, yeah, meters per second squared. This is the acceleration that I'm going to count here in my SUBAT equation. So this is minus 0.88, and we don't need the time. So we are going to use a SUBAT equation without the time, which is this one. V squared is u squared plus 2as. V squared is 0. U squared, 6x squared. Minus, because it's deceleration, 2 times 0.88 s. Yeah, so this minus comes from here. I just put it at the front. And from here, we get that s is 20.38 meters to 2 decimal places. Yeah, like here. This is to 2 decimal places. This is more than the 20 meters that takes for the buggy to stop. So that means the skater hits the trolley, the buggy, yeah, because it needs 20.4 meters to stop, while the other has to stop 20 meters. Yeah, so the skater hits the buggy as he or she needs. I don't know if it says it's a girl or a boy. Yeah, it doesn't matter. He or she needs 20.38 meters to stop completely. and the buggy only 20 meters, yeah? Something like this. It's up to you how you explain it. You have to write a line saying that the skater hits the buggy, yeah? Explain the change in motion that the driver noticed. So you read here, the driver noticed, so when the roller skater released the rope, the driver noticed a change in motion of the buggy, and then it brings to rest. This change in motion is because the skater released the rope. So this tension disappears for the roller skater, but it disappears as well for the buggy. So the resultant force is now going to be 300 minus 140. Yeah, I'm not taking away this one. So the resultant force is greater and acceleration will be greater. Yeah, it will increase without the driver doing anything. So we can write something like, there is no tension anymore in the string, there is no tension. So the resultant force increases. So the acceleration of the buggy increases, the acceleration. Again, you can explain with your own words. Buggy increases. But that's what happens, yeah? And that's all with this question.